Okay, so this is a bit of code I just finished up or got working. So in Kicad we have the option of grabbing some of these footprints and moving them within our user grid, and that works just fine as long as we have no rotation. It's very easy to move things around and have them snap. Have them snap next to each other. And then we have this appropriate spacing between the switches. And then, as you can see, it's very easy to realign them however we like. We still get this appropriate spacing between it, no matter what. Now the problem arises when we change our rotation to something else. And now we can find that we do not get the alignment that we want very easily. And then you have to change this to something smaller, and then you try to eyeball it, but it's not the same. So what we do instead, I wanted something that would be able to realign this a bit easier. So let's take this center switch here, K9, and we'll put, or K8 I guess, it doesn't really matter, that, K7. So we'll center on K8. Let's put this up here. So K8 right here, we'll take this, that's being aligned with K9 down here, and we're going 16 degrees. This is our rotation, which is the same here. And unit is the same size, 19.05. So take this and enter. You can see we've realigned here correctly. And we'll do the same for K7. That's weird. Okay, whatever. K8, K7, 16 unit. So you see we've got our alignment kind of guaranteed here. And we can do this with any other position too. Take a move over here, move it over here, no, not that, move it over here, and do the same thing. Why don't I have history? That's strange. Shift Alt? Whatever. Do these again. And it realigns. Do the first one again. Realigns. So you can see we've still got our consistent spacing between here. And we can do the same thing with diodes or any other footprints. For this one, or we can do half unit measurements. So say this one, we'll move it down just a half, something like that. You can take K8 and K7. 7. Unit divided by 2, or times 2. That'd be 1.5. This is a 1.5 separation. You can see that over here. Just grab this K9 and K10 and do it 1 unit again. K9, K10. So we've got our alignment here, and then we can still orient off of these. So if we wanted K7 to be moved down here more, we can still do that, something around here. And then we do K8, K7, go we make it unit times 2 and hit enter, we'll get our alignment here. So here we've got proper alignment with 2 unit spacing, or we can just change it back to a half unit or a single unit. Back to normal. There's our excellent alignment. Or move it down, excellent alignment. Or move it over here, run the same thing. Oops. It snaps it to that position. So that's how you get the spacing back. And that works for any other angle. It just lets you realign things a lot easier. So this is all the code is. Well, this is the code. You're just grabbing the some extra stuff here. You grab the origin module. You get the orientation of the. I'm not even using that down here actually. I don't think we're copying. There we go. Do I have this? I think I already set that. Okay. So let's do that instead. I don't know what that is. Oops. Put that in there. Okay. So now let's do orientation through here. Why does this work? It has some history on it, and it's a lot easier to. Oops. There we go. We'll add this. K8, K7. Thing. There we are, still moving things around. So now let's do this. Let's go 18. Move that around. Do this, set it to 18. This should reorient and realign off of K8. So there we go. See, we're moving things around. And then we can do K9. See, it moved. That's interesting. It's at an angle. It's not exact. Oh. There we go. Much better. And then we'll use K9 to go to K10. 18. Get this guy. See? So it's easy to remove these, move these around, and make adjustments to them. And again, these are all, it's just automatic. It doesn't care what the position is. We get good alignment no matter what. So that's about it. It's getting PCB new, working on this is a little bit difficult, but once you get it, it's pretty simple. The general function is creating this such that the positioning is correct. obviously. There we go. So if we consider our normal key position, it's easy to calculate on an XY graph where the blue is going to be and where the green is going to be. But if you change it to this angle, then you have to calculate a little bit of trigonometry, and this determines which is your outer and inner selection. So we're calculating it based off the sine and the cosine of it. This is actually not right. No, it doesn't. It doesn't always solve for. Oh yeah, it does. It actually does always solve for adjacent. But that's never mind. The point is, all the code does is it determines whether or not your origin switch and your destination are in which quadrant. So the section within here that you're choosing from is within here, and then it determines whether or not it's within this section or this section. And based on that, you get this selection right here. Right here. So your x origin is plus a, the adjacent, or up here your x origin is plus opposite. And compare this to, let's erase, cool. Compare this to over here where it's plus and minus, and to the up and left is minus and minus. And down here, so x goes to adjacent and x goes to opposite. Down here, x goes to adjacent and x goes to opposite. However, with this division line, we can see that it's x to opposite, and then y is opposite. But it's still plus or minus, and over here minus, 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 minus. So in this quadrant, if you create anything over here, it's always going to be minus, minus. And if you create anything over here, it's always going to be minus plus, which is right here, minus plus, minus plus. But whether or not it's A or O with your x and y is dependent upon this division. So that'll tell you pretty much how it fits together. Whoops, it's too far. So the math to determine whether or not that is in that position is, in our example here, we have 5 by 5. Here's our grid along here on 0, and our starting point is 5 by 5. And we determine whether or not the number is higher to determine if this is in this yellow section, and this will tell us if it is here above this. And over here in this blue section, this will tell us if it's to the left of it, to one side. And this tells us that it is in this area. And then we have to determine if it's above or below that. And this is a simple calculation. We take in this example, this green line splits. And from the center origin, we're determining whether or not these blue dots, for example, are closer to the y-axis, and then the black dots are closer to the x-axis. So we take the absolute value of the subtraction and determine which is closer to which axis. And the bigger number, whichever is larger, gets the adjacent, which is the adjacent line. So that's this line right here. And then the smaller number gets opposite. That's just, here's our opposite, and then our adjacent line. And our hypotenuse is always going to be our distance from the actual move. So that works out to pseudocode of this. Our absolute, if the absolute value of origin x minus target x, which is this being the origin and this being the target, we determine which one's larger, and whichever one is larger gets the adjacent line. So if x is larger, then the x companion becomes adjacent. But if not, then y companion gets adjacent. And then after that, we determine whether or not we're going to do plus or minus, or plus or plus, or plus or minus, or minus minus, and we determine that here by figuring out if our x-axis is to the left, if our target is to the left of the origin x-axis, which is our target. In this case, our target is to the right, which means it would be this one, which is plus plus. So that would be negative, so no. But if it was, you would make it negative, and then you add them together. Yep, so that's it. So that's our individual start here, and then we get our, this is our multiplication. Still getting used to this mouse, it's very tall. And that's how we're determining the same here. This is our OX -1, and that's our calculation. And then we reset it. This is setting the orientation, and then we rewrite it. I think that's it. I hope that's a good explanation. This is probably too long, but all of my videos are too long. If you take the, so use this code. I'll post it to the GitHub so you can play around with it. Make sure that your Python console works. For this you need at least Kicad 5. It has to be 5.0 at least, because all the other versions do not have a working script console. It's broken. So make sure you get yourself upgraded to Kicad 5. Once you do that, then you can work in the scripting console. I guess that's about it. The reason I explain all of this is so that you can take this code and find bugs with it, find problems, find situations where it doesn't work, and with understanding how the calculation works, you can figure out how to make the code better, and then publish updates or pull requests or whatever, so that this code can be better for people who are making ergonomic keyboards, in Kicad at least. It's very nice, very well aligned. Okay, that's it. Thank you.